Hi, I'm Tanja Hayes. Let's learn some economics. Specifically today we're going to be talking about elasticity, the price elasticity of the demand using the midpoint formula. So elasticity in general is if the price was to go up by 1%, by how much would our quantity demanded change in terms of a percentage? So we are looking at our demand curve and we're going to use an example where we start at point 1. The price is $250 and people are demanding 2,000 units. And then we lower the price to $230 and now they want 2,500 units. P.S. What's the best time to go to the dentist? 2:30. 2:30. Get it? Okay. Anyway, continuing on. So the midpoint formula for the price elasticity of demand looks like this. It's very gorgeous if you love math. And if you don't, then just hang in there. So we're looking at basically the percentage change in quantity here. The formula comes from that. And we're using the midpoint. That's why they're averaged out here on the bottom. So we're taking the change in quantity divided by the midpoint. And then we're looking at the change in price divided by its midpoint, which gives us the percentage change in price. Also, because of the fact that the demand curve is always going to be downward sloping because of the law of demand, this will always be a negative number. So we also need to take the absolute value of what we get in the end, which, as you might recall, just means if it's a negative, you just take off the negative sign. So here's our beautiful formula. So now we're going to plug everything in. Remember, keep track of this is point 1, this is point 2, so we can start reading off. We need our Q2. What's that? Well, we're at point 2, Q2 is 2,500, etc. We're going to plug all of this stuff in here. Maybe we'll do it right here. So Q2 is 2,500, and then we're subtracting off Q1, which is 2,000. And then we're going to divide by. Now, if you look at this formula, there's a divided by 2 in this denominator of the denominator, and there's a divided by 2 in this denominator of the denominator. And math would tell us that they cancel out. So you know what? Let's not even deal with them. So here's a simpler formula to really use. So we can just do the addition now on the bottom of these quantities. So 2,000 plus 2,500. All right, so that whole smackaroo is going to be divided by, that's what this symbol is telling us. Same thing, but for the prices. So our P2, we read off our 230. 230 minus 250. See, that's where the negative is going to come in, which we're then going to cancel out. And then on the bottom, we're just going to add these amounts together. Our P1 plus P2. Where did I get those? Well, P1 is just the price at point 1, 250. And P2 is just the price at point 2, 230. So that's where everything is coming from. And yes, absolute value, all of that as well. Now, we could plug all of this into our calculators if we are pretty good at knowing when to put in parentheses and orders of operations and all that. I like to do a little head calculation first because they're really going to type in 2,500 minus 2,000. That's 500. Let's not waste our little calculator fingers for that. And then we have 4,500 on the bottom there. And then that whole thing is going to be divided by, here we have a 0.2 if we take the absolute value, and then we have 4.80. And so now if we do all of that division, we would come out with a number such as 2.67 if we round to 2 decimals. So our price elasticity of demand using the midpoint formula for this example is 2.67. And that's basically telling us that in this area of the graph, anytime the price goes up by 1%, quantity demanded will go down by that 2.67%. So price changes, quantity changes more. So anytime that we have an elasticity greater than 1, like in this case, we say that that's elastic. The demand is elastic. If we had gotten an answer where the elasticity was less than 1, we would consider that inelastic. That's all for now. See you soon.